Hi everyone, and welcome to this showcase of making a new game using Incisor. My name's Veronica, and I had the opportunity to intern at Incisor this summer. While I was there, I was given the exciting challenge to create an entirely new game using the Incisor platform. I'll be making this falling objects game where the player moves the character back and forth to either catch or avoid objects falling from the top of the screen. When I was working on the game concept, I went through a bunch of different thematic ideas and ended up choosing the one I was most excited about, Fork Your Food. You play as an angry chef who's just been laid off, and you have to build gross recipes by catching bad things like saw blades and poison, while avoiding real food like tomatoes and sauce. The first step is to start making assets for the game. I use Photoshop as my tool of choice, but feel free to use whatever software you're comfortable with, as long as you can export your images as semi-transparent PNGs. I sketched out the main character and scene to help visualize the concept. The setting I chose was a kitchen, and our star is the not-so-happy chef. With some visuals ready, it was time to jump into the fun part, working in Incisor. Incisor's documentation includes a lot of great tutorials covering various features. So if you're looking for an in-depth guidance on setting up a project or using the graphical interface, I highly recommend checking out incisordev.com. So let's go ahead and create a new project. The first thing you can see when you open up Incisor is called the Control Center. You can see your files and projects, or create a new one. So just click on New Project, choose the project location, and give it a name. Now open it up. The first thing I'm going to do is move my panels around to where I want them. I want the timeline panel going across the bottom, and the construct view at the top. I'm also leaving the tooltips up, which will give me information in Incisor about the things I hover my cursor over. The object panel will let me manipulate items, and the hierarchy window will help me order and parent things. Now I'm going to go where the project lives on my computer and open the assets folder. I'll make a new folder for the chef assets. I'll also make a folder for the kitchen scene assets. Since we're going to import all the images at once, we should name them with ascending numbers at the end. This will tell Incisor what order to import them in. Now that we're done, let's go back to Incisor. We're going to use the assets we just added to create a new construct. Constructs are a major Incisor feature. They're collections of different types of scene objects that can be built, arranged, and animated directly within Incisor. I created one construct for the kitchen and another for the chef. Here's how I approached it. In the Construct panel, click Select and New Construct and name it. Now right-click somewhere in the panel and choose New Graphic Stack. Find the folder with your assets and add it in. Now all your numbered graphics will be imported. I'll rename the items and clean things up a little bit. I'll also click and drag some things in the hierarchy window to parent different items. I went through a similar process to get all of the assets for the kitchen in there as well. Now that I have a scene and a character, it's time to bring the game to life. If the chef is going to catch falling objects, he needs to move. This was my first dive into Incisor's timelines and animations. Let me show you how I set it up. Back in the Construct panel, click the Timeline dropdown, which will say Neutral State by default. Then click on Add Timeline and give it a name. You'll see all the objects in your construct appear in the Timeline panel. To start animating, right-click on the object and click Animate Graphic Object. Then choose the parameter you want to animate. The keyframe button, the curve graph toggle, and the value will appear. I'll mostly use position and rotate to animate. Press the keyframe button to add a keyframe and set the value. Now I'll click the curve button and right-click on the keyframe. Depending on what you select, you'll get some handles to change the curves. Now I'll jump forward a bit and show you some completed animations. Here's my running animation for the chef. Let's look at the torso. You can see how manipulating keyframes changes the value on the left, and you can use the curve handles to mess with the tweening between keyframes. Since the neck and head are parented to the torso, they'll move along with any changes I make. But I'm also animating some of these things independently to make things feel more organic. Now it's time to start working with something that was a little scary to me at first: code. But don't worry, I'll go through everything step by step. The first thing you'll need is a code editor. I'll be using Visual Studio Code. I'll drop a download link in the video description. We'll also be using some very basic JavaScript that should be easy to follow along with. Alright, with our editor ready, let's open up the project code. All Incisor projects have the same entry point. You can think of it as the place where the project starts. Locate the file called project.main.js. Inside, you'll find a function named init. The most important element of the game is controlling the chef, so that will be our first goal. But before I can do anything, I need to get my kitchen construct into the scene. You can see everything in our construct view, but our live view, where the game is actually running, is completely blank. That's because we haven't added anything to the scene yet. We'll have to do that in code. So the first thing I'll do is set up variables for my two main gameplay elements, the kitchen and the chef. I'll set my first variable to the kitchen construct by using inc.constructDefs. Incisor's autocomplete will show you all of the constructs available in the project. So we'll click the one we want and type .add, adding it to the main scene. The chef is a little different. His construct is inside of the kitchen construct. So instead of using nc.constructDefs, I'll type the kitchen variable I just made and use .descendants by name with another dot afterward to see everything that's parented to it. Then I'll select the chef. Now I can use these variables to get my kitchen and chef from anywhere else in the code. If I save the code, Incisor will refresh and we can see our elements in the live view. I want to make the left and right arrow keys move the chef around. To get this going, we'll use something called an app event. An app event listens for something else to happen in the environment and then executes any function that's been added to it. So we need to use an app event that can always be looking for whether a keyboard key is pressed down. For that, we'll use fixed update. This is a built-in app event that's updating every frame the game is running. Now we add a callback to the app event. This is the function that will run every time the app event is triggered. I'll just call it fixed update callback. And now we just need to make a callback function with the same name. Inside the callback, I'll start with changing the chef's position. If I type my chef variable with a dot next to it, I can see a lot of options come up in the autocomplete menu. Remember all the stuff we were animating back in the timeline panel? Most of those are parameters we can also access through code. I want the chef moving on the x-axis, so I'm going to find position and type .x. Negative values will move him left and positive values will move him right. I'm going to start by using minus equals. This will subtract a number every time the function it's inside of is running. If I save, we can see that the chef immediately moves off the screen. So we need to wrap this in something so it only happens if a certain key is pressed. All we need is an if statement that looks at the right condition. Incisor has some built-in functionality that registers keyboard presses called nc.keyDownStates. This is a variable that will be true if the key is down and false if it is not. So if we put our position change inside the statement that checks for arrow left to be down and save, we can see the chef is no longer moving automatically and only moves when we press the key. Now we can copy all of this, change arrow left to arrow right, and change minus equals to plus equals. The only difference here is that I'm going to put an else in front of our second if statement. I'll get back to that a little later. Ta-da! We can now control how the chef moves. But even though he's changing direction, it doesn't look like he's turning. So I'm going to simply flip the chef when he changes direction. All we have to do is set the chef's X scale to either positive or negative, depending on the direction. Okay, we're controlling the chef, but he's still just gliding across the floor. So now it's time to hook up some of the animations we made earlier. I'm going to quickly go back to my init function. I'll type my chef variable again, and I can see all the animations available by using .timelines. Now I'll call play on a few animations. This will kick them off in the background, but they won't be showing up just yet. In order to actually see the animation playing, we need to turn up its influence. So back in my fixed update callback, I'll get my run animation and turn its influence to 1 whenever I'm pressing a key. Now we can see the run, but the chef doesn't stop running when the key is released. To fix this, I'm going to make an else statement. This basically says, if there's any situation other than what I put in my if statements, then do something else. So in here, I'll set the influence of the idle to 1. That will have Incisor automatically turn the run influence back to 0. Now the chef will stop when we stop moving him. It's working, but the change is pretty abrupt. What we really want is a smooth transition between timelines. Instead of just setting the influence of our run timeline, let's try incrementing it by small amounts. Then when the chef stops, we can bring the idle back in. Something's still not quite right. It looks like the idle timeline is being played when we're not moving, but since we're constantly adding to it, the influence is going above 1 and causing some weird things to happen. So I'm going to use another if-else statement to make sure the influence of either timeline never goes above 1. If the influence is greater than or equal to 1, I'll just set it to 1. Otherwise, I'll increment it. I'll also do this for the run timeline. Copy that around real quick, and now we have a smooth transition. But it looks like he's still running for a little too long when we actually release the arrow key. So I'm just going to increase how much we increment the idle timeline and speed up that transition. I think 0.05 looks good. Okay, that got a little technical, but that wasn't too bad. We're controlling the chef and it could use a little polish, but it's looking pretty good. So let's get some objects in there for him to catch. I ended up creating around 12 different falling objects. Some are food related and some not so much. In addition, I created shadow versions of each object. These will appear as silhouettes when the objects pass behind the kitchen cabinets. I've also added some updates to the chef construct and added an impact animation that will play when the objects make contact. With our new assets and timelines created, let's head back to the code. We'll start with making the items fall from the shelves. Since our falling objects will look a little different from each other, but also share a lot of the same properties, our goal is to make a chunk of code that can be any of the falling objects, instead of having to keep track of 12 separate ones all the time. So things are going to get slightly more abstract for a second, but stick with me. We're going to go back to the project code folder of our project in VS Code and create a new file. I'm going to call it fallingobject.js. At the top of this new file, we're going to declare our falling object as a class that extends the graphic object class that's built into Incisor already. This basically means that our falling object will automatically have everything that a default graphic object in Incisor has. Now there's a couple things that we need to set up in order to get our new class doing stuff. First, we'll make a function called constructor, and we need to give it a few variables to look at so it knows what it's doing. This is sort of like the init function of our main project. It will come in handy when we start using our class a bit later. Then inside our constructor, we need to call the super function, which basically does the same thing for the outer class, in this case, the graphic object. Okay, now that that's out of the way, let's start doing some more custom stuff. I want to start by setting up a few things that I know every object will share. We've got the main graphic covered already through the graphic asset in our constructor. For the shadow, I'm going to make a new variable and set it equal to nc.addGraphicObject with an open parentheses. Whenever you open a function, you'll see a pop-up that shows if the function needs to be given any variables. So it wants a graphic asset, which will be just a generic thing for now, a parent, which is this object, and a name. The name is what shows up if we want to look at this object in the inspector. I'll just name it Shadow. I also want to push the shadow sublayer way back so that it's always behind the main graphic. I'll set up the impact construct the same way I set up the chef and the kitchen. Now, to get some falling objects into our game, let's head back to project main. Okay, back in our init function, the first thing we need to do is create some falling objects using our custom class. What I want to end up with is a pool of a bunch of objects that I can pull from as needed. So first I'm going to make an empty array by making a new variable and setting it equal to some empty square brackets. Then I'll use something called a for loop to put a bunch of objects into an array. This is a snippet of code that will do whatever is inside of it a given number of times. I have 12 total objects I want to use, but let's just start with one for now. Now inside our for loop, I'll make a local variable using let and set it equal to a new falling object with open parentheses. Again, I'll see a pop-up that shows me the variables I need to give it. Remember all the parameters we put into our constructor of our class? This will be where those things come from. So I'll keep the main graphic generic for now, parent all of these to the kitchen construct, and name them all falling object. Then on a new line, I'll get the empty array we made earlier and use a function called .push with my local variable in parentheses. This will put the falling object I just added into an empty array. Since we parented our falling object to the kitchen, it should be in the scene now. Going back to the inspector, we see a new white box in the middle of the scene. When we inspect it, we can see that it's named Falling Object. Now we just have to tell it what to look like and what to do. We'll start off by positioning it and moving it down. I'll make a function here called setFallingObject, and I need to start it off at a certain height. I'll use the inspector to drag my box to where I want the starting point to be and check the Y position in the object panel. 930 looks pretty good. So back in my function, I'll set the Y position equal to that, save, and update. Looks like it's still in the center. That's because we haven't called this function yet. So back in project to main, let's make a function called dropObject. Inside this function, we need to get our falling object from our array and call setFallingObject on it. To do that, we need its index in the array. So in my init function, I'll make a variable called this.fallingObjectIndex and set it to 0. Then in dropObjects, I'll get my array and in close brackets, put in the variable for the index. I can call my function on this and save again. Now we see the box is where we want it to start. So let's make it fall. To move it, we'll use an incisor function called a swooper. A swooper is a function that tweens between two values. In my falling object code, I'll make a new function called fall where I'll put my swooper. I want to swoop the Y position down, so first I'm going to see where I want the box to end up, which I'll do the same way I found the starting height. -1030 looks good. Now in my code, I'll type this.position.swoop.y and provide my destination value and how long I want the swoop to last in seconds. Then I'll call this function inside of setFallingObject, save, and update. Yay! Our little square is falling down. Now let's make it look like something. I want to use all the falling object graphics that I made, so I'm going to make an array of names. This will eventually have all the names in it, but let's just stick with one for now. I'll start with Bottle Poison. I want to pass an index of this array into my setFallingObject function, and then use the name to tell the box what to look like. So down in dropObject, I'll get the name in the same way I got the object itself, just using the array of names instead. Now let's go back to setFallingObject. In these parentheses, I'll put in a variable that represents what I passed into the function. Now all I have to do is type this.graphicAsset and set it equal to nc.graphicAssets with my name variable in the brackets. Now when I save and update, my box has transformed into a little bottle of poison. But that's a really big bottle. I could go into my assets and scale everything down manually, but it's really easy to do with a simple incisor function. I'll go back to my constructor and just write this.scaleByFactor and put a multiplier in these parentheses. I think it needs to be a little more than half its size, so I'll put in 0.4. Yeah, that's looking a lot better. Okay, now let's get all of our objects in there. Back in project main, I'll go to the loop where I made the falling object and change 1 to 12, which will add 12 blank falling objects to my array. Then I'll add the rest of the names to the names array. Remember plus equals? I'll use that to increment the falling object index by 1 every time the function is called. I'll save and we still only have one bottle. Well, that's because we're only calling this function once at the beginning of the game. We want to be calling it over and over again. To do that, I'll use the incisor function called awaitThen. I'll type nc.waitThen, give it a wait time in seconds, the function owner, and the name of the function I want to call. So now our awaitThen will call dropObject once every second. Let's save and see what that looks like. Alright, multiple different objects are falling now, but after a while the game stops. Eventually, our falling objects index gets bigger than the amount of elements in the array, which causes an error. So we need to cap this index at a max number of objects. We'll do that the exact same way we capped the influence of our animations earlier. So until our white box becomes something, it's just sitting on the screen. We probably want to do some enabling and disabling. In the constructor of my falling object, I'll set it to disable. Then in setFallingObject, I'll enable it and save. Much better, but I don't want them just piling up on the floor, so let's do something with them when they reach the ground. Swoopers can be given a callback function that will be executed whenever the swoop is complete, so I'm going to go to my swooper and set the tween type to undefined. Don't worry about that for now, then give the function owner and name. Let's call it splat. Now I'll make a new function called splat. and put what we want to happen in there. We want the object to go away, so let's disable it. But having them just disappear is a little rough looking. Thankfully, we already have a little animation we can use to spruce it up. Earlier, we added our impact construct to falling object. It has a timeline called splat. So now I'll enable it, set the splat timeline influence to 1, and use a function called play once. Save, and nothing happens. Since we're immediately disabling the entire object and the splat is parented to it, that gets disabled too. So instead of calling disable, we're going to set the visibility equal to false. This parameter doesn't affect children, so our object will disappear, but the splat will still be seen. Now it's looking like how we want it. For good housekeeping, we should disable everything once the whole sequence is over. We can do this in the play once function, which takes a callback once it's complete, and we also need to make sure to set the visibility back to true, or we'll end up with permanently invisible objects. Now we're getting somewhere, but this game won't be any fun if all the objects fall from the same place in the same order. Let's start by randomizing their starting position a bit. I'm going to pause the live view and grab one of our objects. I want to drag it around and see what the boundaries of its X position should be. Looks like somewhere around -350 for the left boundary and 920 for the right boundary. So we should try to randomize the X position within that range. To make things simple, I figured out some more or less evenly spaced positions for the objects to fall from, and made an array of them in the constructor. Now I just want to get a random index of that array to use each time an object is brought in. I got a little bit of help figuring out this math. These math functions are some JavaScript stuff that I won't get into, but it basically gives me a random whole number between 0 and the max number of items in the array. In this case, that's 8. So I'm going to set a local variable called index equal to that, and set the X position of my object to the value of that index in my array. We can use pretty much the same exact method to randomize the index of the objects that will fall. I'll just copy this line, and back in my project main, paste it into the drop objects function. I need to be looking at my names array here, and then replace my old index with my new variable. Alright, now we have random objects falling from random places. But there's one more big step we need to take, and that's having the chef actually being able to catch these objects. So there's a few things that we need to know in order for this to work. We need to know the position of the chef's hand at any given time, the position of the object, and whether or not they intersect. In the chef construct, his hand is separate, so I'm going to access that using descendants by name. But instead of doing .position, we need something a little different. The normal position parameter is relative to how an object is parented, not the overall screen space it's a part of. So we need to use the getGlobalPosition function instead. This will tell us the object's absolute position regardless of its parenting. Since the chef could potentially catch any object at any time, we need to always be looking at all of the objects. Thankfully, we already have a function that's constantly updating. In the same way we are listening to what keys being pressed, we can have it constantly looking at where any object is. We just need to give it the right things to look at. We'll loop through the array of falling objects. Then we can use the I in this loop to get a specific one in the array. The first thing we'll do is write an if statement to only do something if the given object is enabled. Then we'll get the global position of the object. Let's just say if the hand and the falling object's Y position and X position are both equal, disable the falling object. That's not working. Since we're only looking at a single coordinate, we have to be way too accurate in order for that collision to happen. What we need to do instead is look at a range of coordinates. Rather than doing exactly equals, I'll look at whether the falling object is within a 100 unit range in either direction. Alright, now the objects disappear if they hit the platter, and if they don't, they drop to the floor like normal. Might as well hook up our splat here too. We just need to add it to the init function and play it like before, except this time just a little more specific with the positioning. So the last part of this step is to show the items piling up on the platter. I've already made side versions of each item and put them in the chef construct. They're parented to the right hand and disabled by default. I've also numbered them 1 through 30, which will help us know which one to turn on. At the same place where we disable the falling object, we can enable the side object. We just need to keep track of how many we've caught so the right one gets turned on. So in my init function, I'm going to make a number of items caught variable and set it to 0. Then when I catch something, I'll increment that number. Now we can see them appearing, but they're just the default ones I put in the construct. We need to make sure they correspond to the actual item that's being caught. I need a way to get the name of the graphic being used on the caught item, so I'll go back to falling object, and in my set falling object function, I'll define a new variable and set it equal to the name. Now back where we were in the project main, I can reference that. All of my side view graphics have the same name as the falling objects, but with an underscore side at the end. So I'll make a local variable here called side name and set it equal to the variable I just referenced from falling object and write plus underscore side in quotes. I'll copy the side item object we just enabled and set its graphic equal to nc.graphicAssets with my side name variable in brackets. Now the side graphic appears according to the item we caught, but the item still has to pass through the whole stack in order to be collected. We want it to collect when it hits the top of the stack. To fix this, all we have to do is get the position of the top item of the stack instead of the hand, which is always at the bottom. Let's just change our hand position variable to reference that instead. Okay, we've got a chef that you can move and catchable items that randomly fall. We can really see our vision for this game coming together. To bring it home, I want to add a basic level system and a goal for each level. And we'll start polishing some of the movement and add in some music and sound effects. We'll get into all of that in the next part. I ran some ideas by the Incisor team, and we decided that each level should be a recipe order that the chef is trying to get ingredients for. If you catch all the right items on the recipe, then you move on to the next level. So I made a recipe that can live on the left side of the kitchen, and an order line construct that contains elements like the item number and which ingredient and whether it's been collected or not. Since all the order lines are duplicates of each other, the first thing I have to do is use code to change their numbers so they don't all just say number 1. I'll just loop through the number of order lines on my recipe and set the string of each text box equal to that number in the loop. Okay, next I want to populate my list with some random bad food objects. I'm going to make a new array with just the names of the bad objects in it. Now back in my loop, I'm going to get a random number using the same math we've used before, but give it my bad objects array. Now I'll just set the graphic asset equal to the index of that random number. With all that set up, we need to create a system that keeps track of whether I've caught the right object. So I'll make an empty array to hold my current list of ingredients, then push all the bad object names into it. I'm also going to add one more variable called current order line. This will come in handy in a second. Back where we set up the code for catching the object, we can also check if we caught the right one. I just need an if statement that looks at whether the name of the object we caught matches the name of the object we're aiming for. I'll use my current order line variable as the index of the ingredients array I made before. To show the player that they got it right, I'll enable this check graphic that's a part of the order line construct. I also need to increment the current order line so next time we're looking at the right object. Now I'll make an else and play an XFlash timeline that's a part of the order line construct. Lastly, I have a box around the current item needed that moves down as you complete the order. After getting some feedback, it seems like I needed to make things a little bit more obvious. So I added a new construct with a timeline that would bring up a good job or wrong message. The timeline is called toss, and I just enable the right message according to the situation. I also decided to implement a scoring system where you get points for catching the correct item and lose points if you don't. I used a loop to add scores that increase by 100 points to each line item. Now I just need a variable for the current score and an array of scores. When I catch the right item, I'll just add the index of whatever line I'm on to my score tally and set the string of my score equal to that. If I catch wrong, I'll subtract half of that amount of points from my score. My next step was to enable a success or failure screen for the end of each level, and I went ahead and made a construct for each of them, making sure to add the restart and continue graphics as buttons. I decided that if you catch 20 items and you still haven't completed the order, then you fail the level and you have to try again. I'm already tracking the number of items caught, so I'll just use an if statement to check that number. This will be for if you fail. Otherwise, you made it to the last line item, and that'll be what I check if you succeed. Now I'll make a function called round complete that'll give you false if you fail and true if you succeed. Inside this function, I'll reset the elements of the game. I'll start with the stuff I know needs to happen no matter what. I'll remove the fixed update callback we made a while ago so you can't control the chef until you proceed. I'll also use a function called stop all wait thens by callback to stop new items from falling. I'm going to reset a bunch of indexes back to 0 and reset the position of the highlight box. I'll loop through all of the items on the chef's platter and disable them, and do the same for all the check marks on the recipe list and any objects that might have still been falling. I'll set the chef's animation back to idle as well. If this function received true, I'm going to enable the success screen I made and get a new list of ingredients for the next round. If we get false, I'm going to enable the fail screen, but keep everything else the same so you can try the level again. Back in our init function, where constructs were added, I'm going to take advantage of the buttons I mentioned earlier. I'll use add release callback function on the buttons inside my fail and success constructs. This will execute a function when the left mouse button is clicked and released on the graphic. I'll call my function start. In my start function, I'm going to re-add my fixed update callback so we can control the chef and use wait then to kick off the drop object function to get objects falling again. Now we'll be set up for the next round. This is all looking good, but I think the game needs a start screen so the player isn't launched right into everything right away. I made a title screen construct with a play button and added it to my init function. Now I'm going to make sure the kitchen is disabled upon loading, so we have a clean background behind our title screen. I'll add the start function to the play button and enable the kitchen in there. I'll also disable all the screens you're not supposed to see while playing the game. I think we've finally gotten everything we need into this game. Now there's a few things I want to do to really polish it up. We have a system set up for changing levels, but right now, levels don't really mean anything. I want the game to get harder the more levels you play. I'm going to add level and difficulty variables to my init function. In round complete, I'll increment the level when we're successful and set the level number on the receipt to the level we're on. I think the best way to make the game harder would be to have the objects start falling faster. I'm going to try out having them get 10% faster each level, so I'll decrement this by 0.1. Now back in my falling object class, I'm going to multiply the duration of my swoop by my difficulty variable, which I can get to with the prefix PR dot. Now every new level we reach, the time it takes for the items to reach the bottom will increase by 10%. I'm also going to do a couple visual things. I want to make the chef's movement a little less jerky so that it matches what we did with the animations better. So I'll put a speed variable on the chef and multiply his position by it. While he's running, I'll increment his speed by 0.01 and limit it to 1. Now we can see that the chef ramps up into his run. We just need to make sure to set this back to 0 when we're not pressing a key. I also want to give the falling objects a little bit more motion, so let's make them spin as they're falling. I'll just go back to falling object and swoop the Z rotation of the object over the same amount of time it takes for them to fall. I'll need to set the rotation back to 0 and set falling object as well. I think this is a good time to hook up the shadow graphics I made back in part 2. My goal is to make the falling objects look like they're passing behind the cabinets and show the shadow versions when that's happening. I can set this up using Incisor's masking system. Inside my kitchen construct, I added some rectangles that cover the cabinet areas. Using the object panel, I'll go to the graphic objects section and open the masking menu. Check the enabled box and set the type to mask. Under mask groups, make sure main mask group is checked. Then I'll save the project within the inspector. Now I can use these graphics to mask the objects and reveal the shadows as they fall behind the cabinets. Back in my falling object code, I need to make any falling object obey this mask. I'll type this.masking.makeMasked with open parentheses. I need to give it the mask group I checked earlier and say whether I want Incisor to invert the masking. I'm going to say true so that when the object crosses the mask, it disappears. Then I need to do the same thing for my shadow, except set the inverting to false so it only shows up when it's inside the mask. Okay, it looks like the masking is still working, but my shadows are still just white boxes. So in my setFallingObject function, I just need to set their graphic asset with _shadow at the end of the name. I'll save the code and make sure it's all working as intended. Okay, we've got some more polish on the movement and life to the objects, but this isn't a silent film. The last thing we need to do is get some sounds in here. I worked with a composer to come up with some music and sounds that fit the theme of the game. Implementing the sounds is a lot like playing timelines. We'll mostly be using play and play once functions. We also have a swooper specific to sounds called swoop volume. After adding all the sounds to the assets of my game files, I'm going to set the volume of the title music and play it. That'll be the first thing we hear. Now in my start function, I'll play this bell sound for when the play button is pressed, stop the title music, and play the base game music. I've got some footstep sounds for the chef, so inside the chef controls, I'll play those when we're running and swoop them down when we stop. For catching the objects we want, I'll play the bell sound, and for the wrong object, I'll play this buzzer sound. I want to have specific sounds for objects falling to the floor, so I set up a play sound function with a bunch of if statements. This gets called in my splat function. I'm getting a random number that's either 0 or 1 and using that to call one of two sounds for each type of object. With all that done, we now have a complete game! Thanks for going on this journey with me. I learned a lot about using Incisor and game development during this process. Make sure to check out IncisorDev.com, where you'll be able to play and download the code for this game. There's also a bunch of tutorials there that go even deeper in some of the things we talked about in this video. I had a great time making Fork Your Food, and I hope you enjoyed following along with the showcase too. See you later!